My name is Juan Marin, and my time series analysis is based on the box office revenue in North America. This data comes from the statistics portal. Here is the original dataset with a yearly period on the left column that goes from 1980 to 2014, and on the right column is the total revenue for each year in billion US dollars, and the total count for this dataset is 35 observations. This chart shows the revenue for each year from 1980 to 2014, and a trend line that shows us an overall positive increase across the years, with some fluctuations from 2008 to 2014. Based on the forecast method that I will explain later, I want to predict the next 5 years to see if the box office revenue will increase or decrease according to the previous years. This information will be valuable for the decision making of movie producers that need to plan ahead of time the release date of a movie, or also to movie theaters that need to evaluate if this business will still be profitable in the near future. The time series analysis, I tried three different methods: regression, smoothing moving average with 6 and 12 years moving average, and exponential smoothing with alpha of 0.1 and 0.7. For each method, I calculated the error and the mean squared error. Values in red are negative errors that mean that the forecast value is an overforecast. Both 6 and 12-year moving average have high squared errors compared to other methods, excluding the exponential smoothing with alpha of 0.1. For this exponential smoothing, the error and the mean squared error were expected to be high because the smoothing factor is really small, while the exponential smoothing of zero point 0.7 has a really good error value because the forecast values are pretty close to the actual values, giving an alpha closer to 1. In this time series chart, we can see that the exponential smoothing of 0.1 in light blue is really far off from the predicted line, and that also the 6-year moving average in green and the 12-year moving average in purple are way above the regression line. On the other hand, the exponential smoothing of zero point 0.7 and the actual revenue end up being pretty close to the regression line. The methods with the smaller error and mean squared error value were the regression method and the exponential smoothing with alpha 0.7. When trying to predict future years, the regression method allowed me to go as far as I wanted, while the exponential smoothing method showed an error value when trying to predict future years. This happens because the exponential smoothing method requires actual revenue to calculate the forecast value. On the other hand, the regression method showed that the box office revenue will be $12.79 billion in 2020, which is an increase of $2.43 billion compared to the box office revenue of 2014. In conclusion, the most effective forecast method for this data is the regression method. In order to calculate the forecast value in billion dollars for a different year, we have to multiply the number of the period by 2.23 and add 0.26. It is interesting to see that for decision-making purposes, this method shows that the box office revenue will continue to increase through the years, so planning ahead for a movie like an animation movie that takes about 3 to 4 years to complete will be safe and profitable in the long run. In addition to this, the owners of movie theaters can continue to invest in this industry because the general trend shows a positive increase in box office revenue for the near future.